Just last week, autumn felt endless in cities like Paris and London. People strolled in light jackets, parks glowed with color, and cafes buzzed outdoors. The air was mild, scented with damp leaves. Classic European autumn. No one rushed for winter coats. Forecasts promised only gentle rain. Then, overnight, everything changed. A biting cold replaced the mild air, frost-coated windows, and autumn leaves turned brittle. The shift was instant, a sudden plunge into winter. This isn't just a quirky weather event, it's a pattern happening more often across Europe. One day, you're planning a walk. The next, you're scraping ice off your car. The answer lies not on the ground, but high above us, in a massive, invisible river of air. This river acts as a barrier between warm and cold air, and when it shifts, so does our weather. Let's explore how this force can erase autumn overnight. Picture a powerful river of air, the jet stream, racing high above Earth. Invisible to the eye, yet always present, it sweeps across the sky at astonishing speeds, shaping the weather patterns we experience every day. It's not water, but wind, sometimes over 200 kilometers per hour, shaping our weather. These fierce winds can bend trees, whip across open fields, and even influence the direction of storms and rain. Pilots use it for a boost, saving time and fuel as they ride its currents. Storms ride it across oceans, gaining strength or changing course as they go. There are several jet streams circling the globe, but the polar jet stream is especially important for Europe, acting as a boundary between different air masses. It snakes around the northern hemisphere, separating icy Arctic air from warmer southern air. This winding path can stretch for thousands of kilometers, creating dramatic contrasts in weather. This invisible barrier can shift, letting cold air spill south or warm air surge north. When it dips, cold Arctic blasts can reach deep into Europe. When it rises, mild air can sweep in from the south. The jet stream's speed and path control how weather systems move. It acts like a conveyor belt, steering rain, wind, and sunshine from one region to another, often in rapid succession. When it's strong and straight, Europe gets mild, rainy autumns. The weather becomes more predictable, with gentle showers and steady temperatures. But when it weakens or wobbles, the weather turns unpredictable. Sudden hailstorms, unexpected sunshine, or dramatic temperature swings can all be traced back to changes in the jet stream. We rarely see the jet stream itself, but we feel its effects every day, whether it's a sudden gust of wind, a chilly morning, or a warm, sunny afternoon. It's the hidden engine behind storms, sunshine, and sudden freezes. Without it, our weather would be far less dynamic and much more predictable. Understanding it is crucial to understanding our changing seasons. Meteorologists study its every move to forecast the weather and warn us of what's to come. The jet stream is the silent conductor of our weather, orchestrating the ever-changing symphony of Europe's skies and seasons. Think of the jet stream as the conductor of Europe's weather orchestra. When it flows straight from west to east, it brings predictable, mild, rainy weather. This is called zonal flow, a conveyor belt delivering Atlantic air to Europe. The straight jet stream keeps Arctic cold locked away. But when it meanders, forming big loops called Rossby waves, everything changes. A northward loop brings warmth far north. A southward loop lets Arctic air plunge deep into Europe. These waves can trigger record highs or sudden freezes. The jet stream's shape decides if we get gentle autumns or harsh, unpredictable winters. A straight path means stability. A wavy path means extremes. The jet stream's mood sets the rhythm for Europe's seasons. What makes the jet stream wobble? Why does this powerful river of air high above our heads sometimes flow smoothly and at other times twist and turn unpredictably? The answer lies in the dramatic temperature differences between regions. These differences are the engine that drives the jet stream's speed and direction. The jet stream is powered by the sharp contrast between frigid Arctic air to the north and much warmer tropical air to the south. This boundary acts like a dividing line, fueling the jet stream's energy. When the temperature difference is large, the jet stream races along in a strong, straight path, much like a river rushing down a steep mountain slope, cutting a direct course. But the Arctic is warming faster than anywhere else on Earth, a phenomenon known as Arctic amplification. This rapid warming is changing everything. As sea ice melts, it exposes dark ocean water beneath. Unlike ice, which reflects sunlight, this dark water absorbs much more heat, causing the Arctic to warm even faster in a feedback loop. As the temperature gap between the Arctic and the tropics shrinks, the jet stream loses strength. It slows down and begins to meander, forming large loops and bends across the continent. A slower, wavier jet stream means weather patterns can get stuck in place. This can lead to prolonged heat waves, persistent flooding, or cold snaps that refuse to budge. When a ridge forms in the jet stream, it can block rain and bring extended drought to regions below. Meanwhile, a deep trough can funnel in cold air or bring relentless rain, causing rivers to overflow and towns to flood. In autumn and winter, a pronounced trough can trap Europe in a deep freeze, locking in cold air for days or even weeks at a time. The jet stream's new, wobbly behavior is making Europe's weather more extreme and much less predictable, with sudden shifts from calm to severe conditions. All of this is a direct result of our warming planet. As global temperatures rise, the balance that once kept the jet stream steady is being disrupted. The jet stream's dance is changing before our eyes, and with it, the very nature of our weather is being transformed, bringing new challenges for people across Europe and beyond. Let's return to our sudden freeze, a dramatic shift that can catch even the most seasoned locals off guard. Imagine waking up to a world transformed overnight, where familiar streets are blanketed in white and the air bites with a new intensity. For days, a strong, straight jet stream acted like a protective wall, keeping the frigid Arctic air locked far to the north. But weather is rarely static. When the jet stream wobbled, everything changed. A stubborn high-pressure ridge over the Atlantic acted like a roadblock, forcing the jet stream to buckle and dive southward, right over Europe. This shift set the stage for a dramatic weather event. Suddenly, a pathway opened for frigid Arctic air, the so-called Polar Express, to surge deep into the continent, bringing with it a wave of cold that few were prepared for. In just a matter of hours, temperatures plummeted by 10 or even 15 degrees Celsius. The change was so abrupt, it felt as if winter had arrived in a single breath. At first, the invading air was dry and biting, but as it swept over the warm seas, it absorbed moisture, transforming into heavy snow clouds that dumped thick blankets of snow on unsuspecting towns and cities. That's why these sudden cold snaps can bring surprise snowfalls, even to places where snow is a rare visitor. People who expected a mild autumn day suddenly found themselves caught in swirling flakes. The abrupt flip from gentle autumn to deep freeze wasn't just a quirk of fate, it was the direct result of the jet stream's unpredictable path, reshaping the season in a matter of hours. When that invisible atmospheric barrier broke, Arctic air rushed in, transforming daily routines, closing schools, and leaving streets eerily quiet under a fresh layer of snow. It's astonishing to realize that the jet stream's twists and turns, sometimes thousands of kilometers away, can change your world in a single day, reminding us how interconnected our planet's weather truly is. The atmosphere above us is a powerful force, shaping our lives in ways we often overlook. Every shift in the jet stream can ripple across continents, altering the course of entire seasons. The Polar Express isn't just a catchy name, it's a real phenomenon, driven by the relentless energy of the jet stream, capable of turning autumn into winter almost instantly. And that's how, in the blink of an eye, autumn can vanish, replaced by a world of snow and ice before anyone has time to prepare. Take Berlin as an example. In mid-November, it was a typical autumn, mild, cloudy, people cycling, parks full. Forecasts predicted more of the same. Winter seemed far off. Then, the jet stream buckled, and the Polar Express was unleashed. Within 48 hours, forecasts flipped. Heavy snow, temperatures plunging below zero. Emergency services scrambled, road crews rushed to prepare. The city woke to a silent, snow-covered landscape and biting cold. Transport ground to a halt. Flights delayed, trains slowed, roads treacherous. Schools stayed open, but many parents kept kids home. Construction stopped. Homeless shelters opened extra beds to protect the vulnerable. Berlin's sudden freeze shows how a jet stream shift disrupts daily life. It's not just science, it's a real challenge for millions. The jet stream's mood can change a city overnight. Sudden weather flips don't just catch people off guard. Nature suffers too. Plants and animals rely on gradual seasonal changes to prepare for winter. Trees need time to harden. A sudden freeze can damage branches and buds. Migratory birds may be trapped by unexpected cold, making their journeys perilous. Hibernating animals, fooled by a mild autumn, may be caught unprepared and exposed. Insects can hatch too early, only to be wiped out by a hard frost, disrupting the food web. These disruptions ripple through entire ecosystems, affecting birds, mammals, and plants. Nature's rhythm is tuned to slow, predictable changes, not sudden shocks. When the jet stream wobbles, the music changes, and the dancers stumble. The result: stressed wildlife, damaged plants, and fragile ecosystems. Our changing climate is throwing nature's timing out of sync. We're all part of this interconnected system, and all feel the impact. The jet stream's power makes it one of the most closely watched features on Earth. Meteorologists use weather balloons, satellites, and supercomputers to track it around the clock. Balloons measure temperature, pressure, and wind high above us. Satellites map the jet stream's path and strength from space. All this data feeds into models that predict how the jet stream will behave. Accurate forecasts save lives and billions in damage by giving advance warning of extreme weather. Cities can prepare, airports can de-ice, and people can get ready for sudden changes. Studying the jet stream also reveals how climate change is making it wavier and slower. This research helps us plan for a future with more extreme weather. Understanding the jet stream is essential for adapting to our changing world. Europe's sudden winter is a warning. Weather patterns are changing fast. The jet stream's unpredictability means more sudden extremes: warm spells, cold snaps, floods, and droughts. We must be ready, personally and as communities. Pay attention to forecasts, keep emergency supplies, and check on vulnerable neighbors. Cities need better infrastructure, robust energy grids, and improved warning systems. Planning for the unexpected is now essential. Understanding the science behind these changes empowers us. The jet stream's behavior isn't random, it's linked to a warming planet. By preparing and working together, we can adapt to these new weather realities. Science and community are our best tools. Let's face the future informed and ready.